Hey folks, this is another update about my work on real-time editing of issue descriptions. And this week I want to celebrate the release of the first stable release of the multi-platform by RubyGem with a neat little demo, and actually demonstrate what we can do with Ruby. Because I think it's sometimes unclear, or sometimes people don't understand why we need a Ruby version of CRDT and why it needs to be a perfect counterpart to the YJS CRDT we are already using in our front end, or we are planning to use in our GitLab front end. So I have this little sandbox that I use for development of all real-time collaboration related features, because it allows me to iterate quickly and to try stuff that never makes it into the product, like go a bit crazy, that kind of thing. Use a perfect environment in terms of like which editor to use, etc., etc. So what you see here is what I think I should have named it better, but it's called GitLab Docs. With GitLab Docs, you can create documents. You can actually, let me show that because I'm super proud of it. You can log in with your GitLab account, and it supports single sign-on via OAuth 2. So perfect, nice, exactly how it should work. So open a document, start typing and do stuff. Excellent, it works as expected. I could mark it bold. I can do the text editor or the document editor kind of thing. What most people know when it comes, or what most people expect when it comes to real-time collaboration is this feature here, right? So we are on one machine and we start typing, and then on the right side things get deleted or added as well as I type on the left side, and vice versa. So perfect, real-time collaboration done, right? But it's not as easy as that, because we have another part in the system, and it's a quite important one, our server. And GitLab is built with Ruby on Rails, and so we also need to be able to interact with what is the front end here, also on the back end. The reason is relatively simple. Like, just look at when we load this document here, it's instantaneously rendered, but it's not stored on the client side. So how do we store what seems to be a CRD data structure written in JavaScript on the server side? And this is where Ruby comes into play, and I want to actually demo how it is done. So I'm going to open up this nice little Rails console here, and then we will dive a bit deeper into the server side. First, let me load our RubyGem. I should learn to type, and let's create the document. So let's create a new document. The document is empty, there's nothing in there, and we want to actually initialize this text field here. So one important piece of information: this is not stored as pure text, it's stored as a relatively complex XML structure. So I need to go and use the XML element here instead of a map area or text. The name is default because creativity or lack of creativity. And if I print this to a string, what I see is nothing, because it's an empty XML container. There's nothing in there. What we can do though is we can sync our local document with all the changes to our server-side document, and we can do this by using the sync method and applying a diff. The good thing is everything I type here on the left side is already persisted on the server into a database, and I can just request a change from the database and sync it with my in-memory document on the server. So when I do this and I have synced it successfully, what I should see here now is a very complex XML structure. You can see the heading here with hello world, perfect, lines up with what we see on the left side, a couple of paragraph code blocks, etc. So this is all nice and fancy, but what if we want to change something on the server and broadcast it back to the client side? This actually works, and this is pretty cool. So let's try this by changing the heading. So the first child in the element is the heading here. I can actually print this to a string as well. I will see the heading level 1 hello world is printed as expected. And now I'm going to insert additional text at position 1, which is after the existing text, because it's a zero-based offset. And I just say, and I want to say hello from the server as well. So cool. Text inserted. We can again print the heading. We could also decide to just print the whole XML and see if it's in there as well. Fantastic. But we're still lacking like an update on the client side. What we can do here is we can utilize the same mechanism that we use to sync between the two clients, the two front-end clients. We can also just do the same thing from the server. So what I do here is I can use my action cable, my WebSocket connection, and broadcast to the document the latest change I made. So I just take the doc that I created, I take the diff and I broadcast it to the client. And boom, what we see on the client side is an update from what I just wrote on the server. Perfect. So this obviously also works with all the other data structures that we support: maps, arrays, text, and XML text. And it nicely integrates with YRuby and YJS. The whole thing was going to be available within GitLab, obviously, and there's a couple of other things that they had to implement besides YRuby in order to make this work. We need a way to efficiently persist CDT structures on the server. We're using Redis for this. And the other thing is we need some abstraction on top of Action Cable, which is Rails WebSocket implementation, to create a nice way of binding YJS and binding YJS with Action Cable messages. Cool. So that's it. Yeah, and I'm really looking forward to see this actually work in GitLab issues in the future. Bye-bye.